So, hi everyone, I'm Sreedhar. Today I'll be talking to you about writing React in JS to writing React in ReasonML. Like, what is the difference and why it is better to write React in ReasonML. So, let's start. So, all of us write React apps in JS, right? So, even I also have written a React app in JS. So, let's try it out. So before showing you the app, I'd like to show you like the code. So this React app is a very simple app. It just has two states. One is show persons, which would be a boolean, and other would be a person storing the person's state. And now, like if the show person is true, I'll be rendering the persons. Otherwise, I'll be rendering a button so that you can click on that and it will toggle. Now let's try the app. Okay. So this is my app. So you can see here, like there is a show persons button here. So when I click on that, immediately what I see is this red screen throwing an error like cannot read property has own property of undefined. So I think all the React devs have experienced this at least once, and the pain point is we experience this in the production side. Like, yeah, if it's in development side, yeah, we can fix this, but we experience this in the production side. Like, in the production, suddenly the app crashes. So, why does that happen? The app crashes. So, why does that happen? The reason is we have written the app in dynamically typed languages. So what happens, for example, if you write a function like to add two numbers in JS, generally you would write in this way, right? So, but this will work fine if the 5 and 15 are the parameters for sum. Now, when instead of 5 and 15, if you give 5 comma an object, it would return you a string, and this would lead to bugs and suddenly like your app crashes. So what generally we do to fix this problem in JS is like we check the type of these input arguments, right? Like even if it is a number and if it is not man, then only add it and return it. Otherwise, return it is 0. This is what we do. So, but this is complex. Like this code, like when someone sees this, instead of directly looking at what it does, like they have to go through all these steps, and it is unmaintainable because we don't know like in the future what types of data may come and what types of data should be handled under this. And this is not, we are not 100% sure that this code would run in production. Like now it has run, but in the production, like some part may come, like some other different types of variable might come, your code may crash. So if you observe here, like half of the code we write in JS would be like checking for these types and shapes of these variables. So why should we write code to check the types and shape of the variable? Can't a compiler or can something like before pushing to the production, can someone look at your code and say that yeah, this type like this is fine, this is not fine? Like can someone say that? Yeah, it can. That is what happens in statically typed languages. So with statically typed languages, like the entire program is compiled before you build it. So the compiler would tell you that these are the types you can expect for this function. So in the program, if you pass any different types of data, then it would fail with the compiler itself, not in the production. So once you push to the production, it means that it will work without any without any breaking of the app. So, but how do we generally write this function in statically typed languages? What we would do is we write this. I think, yeah. So what we would do is we write a function and we would mention in int as a return type, and the parameters are integers, and so we do this, right? Now this would work like sum of 5 comma 15 would give you 20, and sum of 5 comma some string. What it would do is it would throw an error at compile time. But we love dynamically typed languages. The main reason is you don't have to declare types, right? like we want text, but we don't want to write it by hand. We want the language itself to know that if I add two numbers, then the type of these two numbers should be an integer. So what if I say that instead of this code, if you write this, instead it is statically typed. Like you can write this program, and then if you call sum of 5, 15, it would give you 20. If you give sum of 5, string, it would throw an error at the compile time. Like it would be great, right? That's what this feature is called type inference. So how does it work? So like the compiler sees a plus sign here. So by seeing the plus sign, the number one, the compiler gets to know that number 1 and number 2 are type of integers. So if you pass anything other than integer, it will throw an error. And we are returning the sum of these two numbers, right? So the compiler knows that this sum should also be a type of integer. Yeah, that is what ReasonML is. Like ReasonML is statically typed with type inference and a lot more. So ReasonML is a toolchain for OCaml. Like whatever we write, like generally OCaml is a functional language type with type safety. But to write OCaml, it would be like the syntax is hard to write in OCaml. So what ReasonML does is, what Facebook has done is, it took OCaml and it says that instead of writing this syntax, let's write in the same syntax as we write in JavaScript, and still it would be a OCaml code. Like it would have all these type safety thing and all this. So that is what ReasonML is. And the ReasonML has the type inference, and it has immutables out of the box. Like the default thing in ReasonML is immutability. Like you can mutate values, but the default thing is immutable. And then it has the first class JSX support. Like you don't have to import any packages to convert the JSX to React.js and all this. And there are a lot more. So, but how would ReasonML run in browsers? Like, right? So ReasonML is like whatever we have seen, it's an OCaml, but browsers can only run JavaScript. Here comes BuckleScript. BuckleScript is another tool. What it does is, it's a compiler. It takes ReasonML or OCaml code and converts it into a readable JavaScript and gives you a readable JavaScript file. So that's what, like, we write code in ReasonML where everything is type safe and like where you get to know the bugs before pushing it to the production, before compiling, like before the building, and then BuckleScript would convert that code to JavaScript. So your apps would never break. So let's try. So before that, I would like to show you like how ReasonML looks like, right? So I will show you the function. Like this is how you declare a function in ReasonML. Like this is the same as what we write in JavaScript, but in JavaScript we have some const as a keyword, but in ReasonML itself it creates an immutable variable for you. Like itself creates an immutable variable for you. So, and now when you look at this, like I have never written any types here, but still the compiler knows that this number 1 is type int and number 2 is also of type int. So the result would also be of type int. Now in your code, if you try to pass something like a string, the compiler would throw an error like this expression has type string, but an expression was expected of type integer. So that's what ReasonML is like. And so now to add two strings, this plus is used. So what by looking at this, the compiler gets to know that the name is a string and also the last name is a string, and then the return of these hash strings would also be a string. But there is one important feature here. So generally in JavaScript, like you need to pass variables like in the order, right? Like if there is a function like this, you need to pass the name first and the last name next. But in ReasonML, what you can do is it has label arguments. So you can what you can do is you can pass it as a variable. Like the last name is Reddy and the first name is Sreedhar. So this would be very useful for JavaScript devs, I think. Yeah. So now let's look at the compile, like what bucket script does, what bucket script gives. So when you look at the code, what bucket script has generated, this is same as what we would write, right? So we write code in a ReasonML where everything is type safe, and then bucket script would convert it into JavaScript. So similarly, have similar demos. So ReasonML also has tuples. I think in Python we use tuples, right? In the same way, ReasonML also supports tuples. And there is the switch statement is something interesting in Reason. This is called pattern matching. So what it does is, like for example, there is a place, like there is a tuple. This is the tuple, and now using kernel is a function which takes a variable and checks if the minimum one, the second value of a tuple is kernel string. If it is kernel, it returns true, or if it is not kernel, it would match with this case and it would return false. So why I say this is interesting is, for example, if you remove this case and save it, your compiler will give you an error, like you have forgot to match a case where the middle value would be an empty string, right? So ReasonML gives you, like what ReasonML tells you is, like it lets you write program in such a way that it lets you write in the program in such a way that you would handle all the cases for a variable. And but how do we declare objects and all those in ReasonML? So in ReasonML there is something called as record. The record is the equivalent of JavaScript objects, but the records are immutable by default, and then they are fixed of size, like you can't add fields or you can't remove fields. So first what we do is we declare a type. So place is a type with name as a string, and there is another type called item price with keywords name, price and available. So name would be a string, price would be an integer, available would be boolean, and place would be the same as place type. Now, so these two are type link declarations, like we declare types. Okay, this is what the data would be like. And now when we declare a variable or when we declare an object, like for example, onion is an object, I want to declare it. So name should be a string, price should be a 50, like integer, available should be boolean, and price should be of type this another object called name and string. Now if you, instead of name being a string, if it is an integer, the compiler would throw you an error, like this expression is of type integer, but what is expected is of type string. So name would be should be a string, and then you can access records values like with the same dot notation as you do in JavaScript. And now if you want to create some new object, or like there is also spread out operator in ReasonML. So the spread operator is the same as it is in JavaScript. So and it creates a new record. And similarly, I have another demo. This is called variant. Generally, in any other programming languages, type would be either an integer or a string. But in Reason, what we can do is type can be of different things. Like it can be over a dog, it can be over a cat, it can be over a goat. Right? You can have types as a different variants. That is what the variance is. And like, for example, let petty is a variable, and I have given it a dog. Now, so gives milk is a function which takes an animal, and I would match that animal with all of these. Like if it is a cow or goat, it would return true. If it is a cat or dog, it would return false. Now, as I said, like if you forgot to handle one case like this, if you forgot to handle this, ReasonML will throw you give you a warning, like you might have forgot to match it with cat. So that's what ReasonML helps us. In the same way, this is called variance. Variance can also accept an argument. So now the color is a type, which can be either blue with some value or green or black. So leaves color would be green, sky color would be a color of 50, and use like blue is a function which takes a color and it matches with either blue or green or black. So and there is another variant called option in ReasonML. So what it does is, generally in JavaScript, like you have null errors, right? Why it happens is, like you forget that there is a possibility that this value may be a null. Whereas in Reason, if a value is an integer, it should have an integer assigned to it. It can't be null or something. So how can we create a variable which can be either a null or it can be another type? That's where this option type comes in. So if you declare a type as an option of some integer or string or any other type, then height should be either none or sum of the type. So height should be either none or sum of 40. Now if you pattern match, if you want to extract the value, you should pattern match the %height with either none or sum of height. And so you can also write, like, see, suddenly we can't write all the code in ReasonML, right? We have noticed there's a lot of code in JavaScript. So ReasonML also provides an interoperability. Like you can have your functions in JavaScript, like existing functions in JavaScript, and you can use them in ReasonLand. For example, I have some, like, in utils.js, I have a method called print name. So I would like to use that function in ReasonML. So how would I do that? First, you need to create a binding for that. Like you should tell the ReasonML that it should be in a module called utils.js, and the function name is print name, and this would take a string and return unit. Now this print name will have this type of a function which takes a string and returns a unit, and you can use that in ReasonML. So like when you see the generated code for this, it imports it from utils.js and it uses that utils.print name. So this is the brief syntax of how ReasonML goes. Now we fix our code. Like this is our app in React.js, right? So we fix this using ReasonML. So first of all, we'd like to install ReasonML. So like you can go to Reason React page, and then get started adding. Like you need to add these two packages. So I tell this platform is a JavaScript package. Like it gives all the tools for Reason, and it also has JavaScript. And Reason React, like we have written bindings here, right? For this, we have written bindings to use a function from JavaScript land, right? So Reason React is nothing but a set of these bindings to use React.js functions in ReasonML land. Okay, I think it's installed. So we have installed JavaScript. Now we will be installing Reason React. Okay. We have installed Reason React also. Now what we do is we need to add these two scripts to our package in our package.json. So what they do is whenever you write some Reason code, it would recompile the it would compile them to a JavaScript file. So we'll add this to our package.json. And then I think I would close this. We don't require this. Okay. And then we need to have this base config.json. So it tells Bugwell script like what are the configurations, like from where should I look for reason files and all those. That's it. Now I added reason to your React pack, like React tab. Now we'll start using reason. So what we do is first we'll run the app, and then we'll also run this watch. So what it does is like whenever you save something in reason, it would recompile and it would give you the JavaScript for that. Okay. Cool. Now we'll make it into a reason file. So we'll create a new reason file called app.re. Now, okay. First, how can you like you can just copy paste the entire thing, and then you don't have to use these import statements in reason. Like it works on module system. So and now, like if you want to write a React component in ReasonML, so you need to have this annotation called React.component. So and then the default component, whatever you want to be in that module, should be of type should be named with a make. That's it. Now, okay. Now we want to use useState, right? So we use React.useState, and then generally we are like useState can have two things. Like in JavaScript, what we do is we generally pass a value, right? But useState will also accept a function, so that if you want to lazily evaluate something, like not on every render, but when in the initial render where state is extracted, we pass it as a function. So instead of this, what we do, we provide a function. So React, like in the reason React, the bindings are in such a way that useState would give you a tuple instead of an array. So in the same way, this would be a tuple, and like you would be using React.useState, and this would be a list. So now we need to declare a type of this person, right? So as we discussed earlier, like the JavaScript equivalent of reason is object equivalent in reason is record. So we create a type called person, and the person would have a name of string, and the weight would be an integer, and the height, if you see, there are two types of heights, like feet. One is feet and inches, the other is centimeters. Like generally it would be difficult to model this, but in reason it is very simple. Like you can have a variant for height measurement. Like the variant would be, one variant would be of centimeters, which has an integer argument. The other variant would be feet, inches, which has a feet and inches. So these are the two types. And now height would be of type height measurement. Yes. Right. So now we would change this type, change this to feet, inches of 5, 8, and this would be centimeters of, what was that before, 50, right? Centimeters of 50. And we have one issue here, like this start type of object does not have a height itself. Like that's where the option type comes in. So you can wrap this, you can have this type of a height as an option of this height measurement. So that you can have, like, and if you have some value, you will wrap that in a sum. So centimeters would also be wrapped in sum. And here the height would be none. Yep. So we modeled our data, and now so show persons would, if the show persons is true, initially it is false, but if it's true, what we do is, the reason also has this JS like thing. What it does is, it gives the methods which you use in JavaScript, it gives the bindings for those, like there.array.map, and you take a person and return. So this is the array type in ReasonML, like you need to have this, and yep. So, and also you need to have this entire thing passed to React array, because the React component would always expect a type, return type of React element. So what we are returning here is an array, right? So we need to wrap this in a React dot array, which would take an array and give you an element. So now what's the error here is, you have written app reason, but it could not find a person reason file, right? So we'll also create a person reason file. So before that, what I do is I take these type bindings and I would create a new file called person type that I would place it here. And so if you want to use the types here, you could just open person type here, that's it. Okay. So now we have completed this app.js. What we do is, we, in the same way, we would also have this person component also. So person is this. So what we do is, we would create a new file called person.re. Good. So the same thing, you just take, and what I'm doing is, like previously our code was written in JavaScript, right? So I'm converting it to Ruby. So for the, I need to have this dot component binding on the top, and then it would be like the default component which you want to be rendered. Like you need to have this as a make, and then so it accepts a top called person, right? So you can just directly use, like, this is how we use props. Like the React component takes care of getting the props and like taking it and rescheduling it. Like, otherwise, yeah. So the person would be of type person type person. So we don't require this wait height. So now so if you see the type for person, wait, now person has a name of string, right? So what you could do is you can use person.name, but you need to wrap that with React.string, because React always expects a type call of React element, so you need to wrap that with that. And then instead of this is very, like, when you look at the code here, it's very complicated, like not complicated, but it's not very intuitive. So what we'll do is we'll switch over person.height, and if it is none, render nothing. Like if it is sum of and if it is a type of sum of some centimeters, just render react.int of that centimeters. If it is written sum of feet, inches of comma int, just so what you can do is react.int of, okay. So we can convert these integers to strings, and then we could attach them together, like string of an integer of feet, inches, centimeters. So string of integer of feet plus string of integer of feet, but in between I would like to have some empty space like this. And then so that's it. We don't look at this. Then weight would be, and as I told you, like you need to wrap this string in a React.string. It should take a string and return an element. And now this would be React.string of weight would be an integer, right? So like it to be a string, which can get strings. So we convert it to a string of int. And then we remove it. So there is no return keyword in reason, like whatever the last expression is, that would be returned. So now as you see, it shows some error, like variable centimeters must occur on both sides of this pattern. Okay, I think I have written this wrong here. Okay, fine. And this is on that word. Okay, this is person.word. Okay, now I did not even I will be using just. So now person.re is ready. Once we go back to person.re, which uses this, we add that re. React element. This expression has type just.array.t of person. Okay. So once you make it to another thing is button has on click listener, but on click will always pass an event, right? So this is an error because we are not accepting any parameters. So what if you don't require any parameters, like if the function gives the function wants you to accept a parameter, but you don't want to use it, so you can just use underscore. So and here it would be some like this. And this show persons would be of type React.string. Okay, now I'll fix this code. So what about array? I'll choose one array.map. This expression is type. Okay, now I got the issue for this. See, we are mapping fine. We are giving a function to map, but I forgot to give like persons variable here. Like on what should it map? It should map on persons, right? Yeah. Now, like when you see the code, like everything is compiled and you don't have any warnings. Like if you see here, it shows you, yeah, it has finished the compiling. So just now in the main index.js, previously we were using app, right? App.js. Now we'll be using from app.js, which would return a make function as a, yeah. So I have written an app.rv like this. So let's see what Bubblescript has given us. So Bubblescript has given us this. So this is like readable JavaScript that you get all the immutability and all the static type checking beforehand. Now since our app is compiled, when you run this, like it works, like it never breaks. Yeah, so that's what this is. Okay, we'll go back to slides. Okay, so what we have achieved here is like all these errors, like whatever errors I have fixed, like even I got errors like this, right? Like I have practiced, the code, but I forgot to handle some cases like passing the persons to the array.map, which would generally not throw an error in JavaScript. If you are using JavaScript, it would work fine. It would be and you push it into production, but in production it would have that error. Whereas using ReasonML, I am able to know that this app will never work. This app will not work. It will break in production because I forgot to pass that persons to a map function. So by using ReasonML, like you get to write apps which do not break in production. And as I said, if it compiles, then it works. Like I've seen that it compiles perfectly and without any errors. So I was sure that it would work fine. And it is also easy to refactor. So like if you want to change some shape or some data, ReasonML compile will like take you to the place where this might be, this might be an error, like this shape does not match, something like that. So refactoring would be easy. And you can implement gradually, right? Now what I have written is I have written the two components in ReasonML, right? So, but if you watch this, that index.js is still in JavaScript, right? So in the same way, you can just have these two components, and the rest of all the components can be in the plain old JavaScript or any this of your language. So you can increment gradually, and also you can use JavaScript components in ReasonML. Like I showed you like bindings, right? Like how you use JavaScript functions in ReasonML. So you can increment gradually. So like you get the Discord. Like if you have any questions, Discord is a place to have, because it has the people there are very friendly, and you can also